Hi, myself Dr. S.K. Bushra, former HOD, Department of Physics, Cotton University. This is the second of a lecture series for Class 12 Science students. The subject is physics. The topic is electrostatics. Chapter 1, Electric Charges and Fields. Of this chapter, we have covered part 1 of lesson 1. The lesson 1 contains electric charges. This is part 2 of lesson 1. In this lesson, we'll discuss the following. How do material bodies get electrically charged? Basic properties of electric charge. And finally, what is electrostatics all about? First thing first, how do material bodies acquire electric charge? There are several ways in which a material body may acquire charge. One of the ways is the charging by rubbing or triboelectric charging. We know that different types of atoms and their combinations constitute material bodies. It is therefore only natural that material bodies will differ in electrical properties. A particular electrical property has a pivotal effect on triboelectric charging. Here, we are referring to the property of electron affinity. This property refers to the probability of getting hold of an electron by a neutral atom of a material body from a proximate foreign atomic environment. Let us rub a piece of wood with a piece of woolen cloth. In the process, the electron clouds of outlying atoms of both the materials penetrate the sphere of influence of each other's nuclei. The interaction between electron clouds with foreign nuclei leads to one material getting hold of electrons from the other. Of course, the direction of electron migration is determined by the relative electron affinity of the bodies involved. The electron affinity of wood is greater than that of wool. So the atoms of wood begin to acquire electrons from the atoms of wool during the rubbing process. The result is the piece of wood acquires few more electrons than normal and becomes negatively charged. The piece of woolen cloth loses a few of its electrons and becomes positively charged. The pair of objects in question always end up with equal amount of positive and negative charges. Consider the series usually referred to as the triboelectric series. The series shown here is not exclusive or complete. I have just put some familiar objects in the list. If any two materials from the series are rubbed against each other, the materials appearing higher in the list will be negatively charged. Let us rub a glass rod with a piece of woolen cloth. This is the situation before rubbing. The piece of woolen cloth and glass rod are both in neutral condition. This is the condition after rubbing. The glass rod loses electrons to the piece of woolen cloth and becomes positive, while the piece of woolen cloth becomes negative. Next, we rub a rubber rod with a piece of woolen cloth. This is the situation before rubbing. Both the piece of woolen cloth and rubber rod are in neutral condition. This is the situation after rubbing. The rubber rod gains electrons at the expense of the piece of woolen cloth and becomes negative, while the piece of woolen cloth becomes positive. The other methods of charging include charging by induction and charging by conduction. But these methods apply to conductors only. Now, for the asterisks, we'll talk about these methods in a subsequent lesson when we'll be discussing conductors and non-conductors. Two fundamental observations regarding electric charges have been, in fact, these two observations are very, very well known. Like charges repel one another, while unlike charges attract one another. Now, let us come to the basic properties of charge. They are quantization of charge, conservation of charge, and additivity of charges. Quantization of charge, slide 1. We have learned that the protons, there is an asterisk marks here, and the electrons are fundamental in nature, meaning they are not further divisible. The protons and electrons are the basic charges of the universe. Hence, the basic unit of charge is the charge of an electron or a proton, which is E equal to 1.6 into 10 to the power minus 19 coulomb. For the asterisk sign, later we will be learning that a proton consists of two up quarks and one down quark held together by strong force. Quarks carry fractional charge, plus 2 by 3 E for up quark and minus 1 by 3 E for down quark, but they do not exist in free form. Therefore, we'll consider protons as fundamental, at least in the standard of class 12. The adjoining figure shows the internal structure of a proton consisting of two up quarks and one down quark. Quantization of charge, slide 2. We have also learned that charging of material bodies occurs on account of migration of electrons from one atomic environment to another in a static positive background of protons. The charge in a body is therefore always on account of either an excess or a deficiency of electrons than the normal. Quantization of charge, slide 3. Thus, the charge on a body is always expressible as Q equal to NE, where N is any integer, positive or negative. A positive value of N indicates a deficiency of electrons, while a negative value of N indicates an excess of electrons in the body. The fact that electric charge present in a material, present in a material body is always an integral multiple of E is referred to as the quantization of charge. I'll read the last paragraph once again. The fact that electric charge present in any material body is always an integral multiple of E is referred to as the quantization of charge. Conservation of charge. The principle of conservation of charge means that the total electric charge in an isolated system always remains constant. We have observed that in charging by rubbing, the pair of objects get equal and opposite charges. Thus, net charge produced in the process is zero. Consider another example. In some reactions, charged particles are created. For example, a neutron may decay into a proton and an electron. As the proton and electron carry equal and opposite charges, the total charge remains zero before and after the event. Additivity of charges. The total charge present in a body is the algebraic sum of charges contained in the body. Algebraic sum means taking into account the sign of terms of the sum. If Q1, Q2, Q3, ... are the charges present in a body, then the net charge of the body is Q equal to Q1 plus Q2 plus Q3, ... For example, if plus 2, minus 3, plus 1, plus 4 are the charges present in a body in some units, then the total charge of the body is Q equal to plus 2, plus or minus 3, plus or plus 1, plus or plus 4 equal to plus 4 units. Finally, what is electrostatics? Electrostatics or statical electricity is that branch of physics that deals with stationary electric charges. We have come to the end of lesson 1, part 2. In the next lesson, we'll talk about conductors and non-conductors. Non-conductors are also called insulators and also called dielectrics. Thank you.